Welcome to the course Digital Transformation and Technological Innovation. So, we are into our fourth module, that is Tech Advancement and Internet Basics. So, we are into our last few sessions. So, let us continue our discussion from where we left in the previous session. So, our next important question that we would like to address in this session is how are routers and computational nodes connected. So, essentially we are looking to focus on the wiring part of it or the connectivity part of it, right. So, routers are making up the internet, right. They are essentially sitting in between the computational nodes, right, and we talked about the routers in the previous session. Now, routers themselves can be connected wirelessly or by cables, right. So, these are the two options that are there, either the wireless connection or the cabling, right. Now, if we are talking about the short distances, then in short distances, for example, we are in a home setting, we are having our home setup, or we are having our own organizational setup or business setup. So, in those setups, whatever rooms we have or cubicles we might have, the computers and all that, those computers need to be connected to the LAN, and they needs to be eventually connected to a router, right. So, for that kind of connectivity, Ethernet cables are used, right. So, essentially this is referred as this comes under the category of short distances. So, when the connectivity is to be ensured over short distances within the home setup or within the business setup, then Ethernet cables fill in that role. And what are Ethernet cables? So, these are likely to be twisted pair copper cables, right, and most of us have seen the LAN cables, and we can, through the connector, we can also visualize the twisted pairing thing that is there. So, these are twisted pair copper cables with transmission sent via electricity, right. So, we have earlier spoken about in our introductory modules about the how what the data is about and the zeros and ones, and how electrons, the state of electrons can manage that. So, essentially electricity is passed through these Ethernet cables or twisted pair copper cables to manage that transmission of data in the form of zeros and ones. So, over short distances, Ethernet cables can be used in a home setup or business or organizational setup. Now, if we are looking for long distances, we are looking to cover long distances, then we need long haul cables, and they will be responsible for carrying the whole data traffic, because they will not be just carrying the data for one or two devices that are there in a home setup. Rather, they will be covering for many more homes and businesses and lots of computational nodes, routers and all that. So, therefore, long haul cables they are used to carry lots of data traffic. So, usually these are fiber optic lines, right, and these are fiber optic lines, these are actually glass lined cables, and transmit light. So, light is obviously much more superior in terms of transmitting the data when we compare it with the electricity and these twisted pair copper cables. So, the speed that you might experience is limited or constrained by the Ethernet cabling or the copper cabling that is there, because the electricity is being used there for transmission of data. But in case of fiber optic lines, the speed is much faster, because it is the light that is being transmitted, which is way faster in comparison to electron speed, right. Now, if we do cost comparison of network cabling, then fiber optic networking equipment, this is generally more expensive than copper equipment, and though the cost gap is closing, because the technology advancement we have talked about, that is continuously improving the production technology for many of these hardware, computer hardware component, including the networking hardware components, that is improving, and there is because of that the cost is going down. So, the price elasticity and fast cheap computing concept applies in the case of networking also, or networking hardware also. So, fiber optic networking equipment is generally more expensive than copper one, but the cost gap is closing. So therefore, the copper equipment, the home and business setup, which users at the home or the business, they might not be able to afford the more expensive option of fiber optic connection. So it makes sense for the prevalence of Ethernet cabling, copper based Ethernet cabling and all that in home and businesses. But when it comes to managing the main internet infrastructure, and managing the huge amount of data traffic that would need to be transmitted, fiber optic networking is something that is operated by ISPs and telecom firms, which these firms can obviously afford to lay out this infrastructure, right. So this cost gap is closing, and raw cables are pretty much comparable in price. But if we look at the electronics that is needed in terms of transmitting light instead of electrical signals, that will actually drive up the total cost of fiber installations. So electronics part of the fiber optic cables is actually costly, and with the technology advancement we might hope that this will also reduce further, right. So this was about cost comparison of networking cabling. Now moving on, we look at the internet across the globe, right, the global internet. Then what is the main infrastructure that is actually running and that is supporting the internet across the globe. So that is referred as internet backbone, and that is it is in a sense foundation of the internet. Because of this internet backbone that is there, the connectivity across the continent, across the globe, connectivity between the continents and across the globe is actually feasible. So internet backbone is like a principal data highway of the global internet, right. And so what this internet backbone is about, we will talk about. So because of this, we are able to access a website which is hosted in US across the ocean and so many continents in between, right. So this internet backbone, this principal data highway that is there, that does the heavy lifting in terms of carrying massive quantities of data over vast distances in milliseconds, right. So generally when we talk about transmitting data, the time is measured in the form of milliseconds, the latency, right. So internet backbone, the principal data highway does this massive does this heavy lifting of sending or carrying massive quantities of data over vast distances. So it consists of massive network of interconnected high speed fiber optic cables. So the backbone is actually made of fiber optic cables, right, and then there are core routers which actually span countries and oceans, right. So the connectivity goes through the oceans and countries, and there are some core routers at designated places, and high speed fiber optic cables are actually used to manage the interconnection and manage this whole massive network. So this put together, high speed fiber optic cables, core routers across the countries, spanning countries and oceans, that makes up the internet backbone, right. And that is the one which makes it possible for a end user to access a website hosted in some other country across far away continent, right. Now let us look at what are the components of this internet backbone. So first fiber optic cables. So what are fiber optic cables? So we already looked at in the previous slide that these are bundles of glass strands, and that use light pulses to transmit data. So light pulses, instead of electrons were used in copper cablings, in case of fiber optic cables, light pulses are used to transmit data, and at nearly the speed of light. So this gives the speed why the whole transmission is completed in milliseconds across the continents, across the globe, because this data is being transmitted at a speed of light over thousands of miles, right. So therefore in milliseconds the transmission can take place. So, fiber optic cables are important component of this backbone. Then there are submarine cables, right, the cabling that is in the ocean floor. So, these are actually heavily armored, right, because there is no way of doing maintenance in the ocean floor, right, and therefore whatever laying of fiber cables is happening, it has to be protected during the installation itself. So, these are heavily armored fiber cables and laid across the ocean floor to connect different continents, right, because many continents there is no land connectivity, they are across the ocean. So, therefore, this submarine cabling is done, and these fiber cables are actually very heavily armored, so that they can bear in case there is a possibility of some damage because of the ships passing by and so many items being thrown in the ocean, and they might actually drop at these cable points and therefore disturb the or cut the cables. And many of the ship components which sink, they might have sharper edges, and they might actually cut these submarine cables, and eventually they might affect the internet backbone. The connectivity to the continent might go away, right. So, therefore, these are heavily armored to meet that eventuality, right. Then there are core routers. So, core routers, these are actually specialized ultra fast routing hardware. So, this quality of this routing hardware is much better, this is ultra fast also and specialized. So, this is capable of managing trunk speed over 100 Gbps. So, there is a lot more data that is actually passing through these core routers. So, these core routers should be able to bear this kind of transmission that is happening all the time, right. So, trunk speeds over 100 Gbps. So, this routing hardware should be able to bear that, right. And then these core routers, they also play the role of traffic controllers. So, they essentially sitting in special points where they control the traffic across continents or nations. So, they use the border gateway protocol BGP to direct data packets efficiently, and because how well these core routers are functioning, that will actually determine how fast the data packets reach their destination. So, the efficient network path is something that is needs to be determined, so that the traffic can be controlled, congestion can be controlled. So, they follow this border gateway protocol to do this. Then there is internet exchange points that we have spoken about in previous sessions as well. So, these are actually physical locations where different backbone providers. So, internet backbone might actually be provided by in certain large telecom firms from mostly from developed countries. So, those telecom firms which are actually providing this they are providing the different segments of internet backbone. So, essentially they are backbone providers. So, these internet exchange points provides a physical location for these different backbone providers. So, these could be firms, telecom firms from different countries and continents, and these need a location where they can exchange traffic, right. So, backbone providers and large networks also. So, they physically connect to hand off traffic to one another, right. So, there has to be connectivity because different parts of the backbone are managed by different telecom firms, and we need an internet exchange point, some sort of physical location where this exchange of traffic from one provider to another provider happens. So, these are referred to as internet exchange points, and they play an important role in terms of managing the internet backbone. If you recall our discussion in cloud computing context, right. So, some of these providers that we were saying that they also become the cloud hosting provider, cloud provider, right, because they are already into this kind of service which is very high demanding in terms of infrastructure and cost and installation and everything. So, therefore, internet exchange point is another important component of the internet backbone. Then next part is the last mile connectivity, right. So, what happens when it comes to delivering data to a specific end user device, right. So, essentially the experience, end user experience is determined by how the end user device is that how the data is delivered to end user device. So, the speed at the end user side of things, that actually determines the experience. So, therefore, last mile connectivity, when we talk about it, so it plays an important role in the whole internet to work or received well among the mass users. So, this is more like final leg of telecommunication network, right, that physically connects a service provider to the end user's home or businesses. So, telecommunication firms would be doing the this would be doing the installation for last mile connectivity, and they will be physically connecting the service provider to end user's home or business, right. And in a way, this last mile connectivity is in a way is shortest physical distance we compare to what is happening in the internet backbone. The last mile connectivity actually deals with only the shortest physical distances, but as it turns out that it is often the most expensive, complex and slowest part of the entire network journey, right. So, while it is we are talking about the shortest physical distances for last mile connectivity that needs to be managed, but it turns out to be the expensive, complex and slowest part of the network. But the experience of end user is important for any application that is delivered over internet, right. So, this becomes in a way bottleneck, this becomes in a way a critical point, right. So, there are lots of focus that has been given on the last mile connectivity or improving the last mile connectivity, right. Now, to understand the last mile connectivity a bit more, let us look at the Amdahl's law. So, what does Amdahl's law says? That it says that overall speed up of a system. So, we are looking to speed up a system, that speed up process would actually be strictly limited by its serial component, right. So, if there are serial component in the system, so the speed up will actually be limited by that particular component, serial component, because it is the part that cannot be split up or run in parallel. So, it cannot be improved, it cannot be split off or we cannot do parallelization in that component, and therefore, speed up will not happen in that component, and it will sort of act as a bottleneck, and therefore, the overall speed up will be limited by how much we improve this part, right. So, serial part in case of the internet context and the last mile connectivity context, it is a fixed speed limitation of the last mile, right. So, the last mile connectivity, that is sort of having a fixed speed kind of scenario facing a speed limitation. So, overall network, the other part of the network, the main internet backbone, the fiber optic lines on land or ocean floor. So, those might be much faster, but the last mile connectivity, that is like giving the limitation there in terms of speed. So, that becomes the serial part, and the parallel part, as I said, vastly upgraded backbone and regional networks. So, while the regional networks and the backbones once they are upgraded there is a speed up, but what happens at the end user side, what happens in the last mile connectivity, that will determine the overall speed of the system. So, any limitation in the side of last mile connectivity, that will actually hamper the experience at the end user side, right. So, once we apply Amdahl's law to the last mile, essentially what are we saying? We are saying that upgrading the core internet infrastructure fails to improve the end user experience due to bottlenecks in the local connection. So, if there are bottlenecks in the local connection, the end user experience is not going to improve. So, we will fail to improve the end user experience despite our upgrades to core internet infrastructure. So, Amdahl's law clearly gives away this particular warning. So, then we need to work on last mile connectivity, and one of the solution is the broadband technology. So, these broadband technology essentially target the last mile connectivity, target improvement for the last mile connectivity. So, let us look at some of the aspect of the broadband. So, the broadband is a high speed always on internet connection that transmits massive amounts of data simultaneously across a wide band of frequencies. So, there are lots of frequencies, wide band is there. So, there is a wide band of frequencies and data is transmitted simultaneously across this, right. So, therefore, because there is a wide band of frequencies and through these different channels the data can be transmitted simultaneously. So, therefore, it improves the speed, right. So, it becomes high speed always on kind of internet connection, and so the main technology, the main technology behind broadband is actually this simultaneous use of wide band of frequencies, right. So, how does it work? So, it works by dividing a single transmission medium. Right. This transmission medium can be any of the delivery technologies that we will be talking later. Few of them we have touched upon. So, it works by, so broadband technology, they work by dividing a single transmission medium. It could be a cable or wireless frequency, right, whether it is about the cable or the wireless. So, it divides that whatever it is, it divides that single transmission medium into multiple distinct channels, and now these distinct channels can be used to transmit data for different applications. So, overall speed improves, overall end user experience improves, right. So, end users can actually run multiple applications which all are receiving data from the internet, or they are basically web applications or internet applications, right. So, this is the main role of broadband. So, in a way what it does, what is the benefit, overall benefit of broadband is that it enables a movie download, right, a video call, any app update. All of us, we go use our smartphones, we are doing app update, at the same time we are also making a call, right. So, it enables a movie download, a video call or app update at the exact same time without signals crashing into each other. Because why that is possible? Because there are multiple distinct channels. So, different channels can be allocated to different applications, whether it's movie, whether it's a download or video call or app update. So, there is no signal crashing, and at the same time it will enable uses of these different applications at the same time, right. Now, then how do we define a broadband? So, what kind of connection actually qualifies as a broadband? Because we said in the previous point that a single transmission medium is actually divided, the single transmission medium can be cable or wireless frequency, right. So, when a cable when this cable medium or wireless medium, when we can call that as a broadband, whether it is meeting, whether there is a criteria to say that a particular a connection is a broadband connection or not. Now, over a period of time, technology advancement has happened and keep on happening. So, the technology advancement over time actually influence the internet speed, right, and these therefore it also has an impact on what qualifies as a broadband, right. So, technology technology advancement over time influences internet speed, and that has an impact on what qualifies as broadband connection. Now, if we look at some of the broadband definitions, and if we take the example of United States, then we will see that these are some of the minimum speed that are there. We see that 100 Mbps for download bandwidth, and we also see that 20 Mbps for upload bandwidth. So, those kind of numbers are there for a connection, for a network or internet connection to be categorized as a broadband connection. So, this much of speed has to be there, right. And if we look at India, this number is much smaller. This is just 2 Mbps for download, right. So, in India we just have this speed of 2 Mbps for download, then that might get categorized as a broadband. So, what it means to be broadband connection in developing country and in developed country, that might be very different. So, the experience for the end user in the United States when they have the broadband connection, and when a same user when a end user in the India has a broadband connection, that is very different, because this definition differs, and therefore because it has a bearing on the the backbone that is there, the internet backbone that is there in the country, and the kind of support that it can provide. So, obviously population and the number of internet users that are there in countries, that also matters, because in India the number of internet users are way more than in other countries. So, it is the same bandwidth that is being shared by more people in India than in United States. Therefore, the population plays a role, right. So, it pretty much going like per capita income, because the same thing is shared, and therefore the bandwidth broadband definition reduces just like per capita income reduces, right. Then we talked about the bandwidth here. So, what is bandwidth? So, this is bandwidth is the maximum amount of data that a network connection can transmit over a specific path in a given amount of time, right. So, that defines the bandwidth. So, this is when we said broadband definition 100 Mbps for download and 20 Mbps for upload. So, this is in a way is a bandwidth, that is a maximum capacity that network connection is actually can support, or that network connection can actually transmit over that specific path and for a given amount of time, right. So, how this is measured? Usually measured in bits per second. So, small bit BPS. So, you can see megabits per second Mbps and gigabits per second Gbps. So, this is how it is measured, right. And now you can see here to define this broadband we were using Mbps. So, this is megabits per second, right. So, here you can see that the download limit is actually 50 times more in case of US compared to India. Now, this was about bandwidth and how it is measured. So, maximum amount of data. Then there are some confusion that might arrive when we say bandwidth, throughput and speed. So, to clarify the confusion that might be there, here we are defining it again. Bandwidth is like maximum capacity of the network. So, it could be like when we said up to 100 Mbps. So, essentially that network has the capacity to actually transmit data at this rate 100 megabits per second. So, it is connected to, when we say bandwidth, essentially we are talking about the maximum capacity. When we say throughput, we are not talking about the maximum capacity, we are talking about the actual thing in action. So, the actual amount in action that is happening, the actual amount of data successfully delivered. So, we are essentially talking about that, right. So, this might get reduced due to Wi-Fi interference might be there, and we might only get 80 Mbps instead of the maximum capacity. So, because of interference only 80 Mbps is there. So, therefore, the throughput might is more likely to be lower than the bandwidth, which is the maximum capacity. And when we say speed and or in other words latency is also can be understood same way. So, when we say speed, it is about time it takes for a single packet of data to travel from point A to point B, and is generally measured in millisecond. So, hope this clarified the difference between bandwidth, throughput and speed. So, we will stop at this point in this session, and we will continue our discussion in the next session. Thank you.